So welcome back. Let's now solve question 6. So the question is define star on Q, which is rational numbers. So Q is just a set of rational numbers as x star y is equal to xy over 5. Note that Q stands for rational numbers, which I've talked about. So the first question is star a binary operation on rational numbers? So here you don't just guess, you have to check if at all there is a probability of you replacing two rational numbers where there is x and y in this expression, and you get you get the answer which is not a rational number. If there's no probability, then star is a rational number. But if there is a chance that if you replace maybe any two rational numbers where there's x and y, the answer that you get is not a rational number. Maybe you get the answer which is an irrational number. That implies that star is not a binary operation on R. But in this case, according to what you can see here, when we get any two rational numbers, we replace them where there's x and y, you discover that the answer that you get is also going to be a rational number. Hence, star is a binary operation on the set. Hence, star is a binary operation on the set of rational numbers. Sorry, there was supposed to be Q here. Okay, so this is, let me give an example where star cannot be a binary operation on rational numbers. So if you have maybe x, let me use a and b for the sake of not confusing it with that. So if a star b, if you have a question like this, a star b is equal to, maybe you have x plus y over x. So on this operation, star, oh, sorry, I'm using x again. Okay, let me use a and b here. So we have a, b, then let's say the denominator is also a. So on this operation, we can say star is not a binary operation on the set of rational numbers. Even if there were real numbers, star wouldn't have been a binary operation. Why? Because there's a way we can put a zero there. When we put a zero where there's a here, the denominator, the answer will be undefined. So undefined is not part of the set of rational numbers. Hence, we can say star is not a binary operation on the set of rational numbers, real numbers, or or whole numbers. Yeah, but if we had natural numbers here, we had natural numbers, it means that star would have been a binary operation because we don't have zero in the set of natural numbers. We don't have zero in the set of natural numbers. Natural numbers start from 1. So meaning when you replace any number starting from 1 going up, while there's a, you will not have any undefined solution here. All the solutions that you are going to get will be defined. All right, so that's what it means. So according to this question that we were given, star is a binary operation on rational numbers. So they're asking, is star a binary operation on rational numbers? The answer is yes. Here you don't have to explain anything unless they ask you to. Okay, so we move on to part B, the second part rather. It says determine whether star is commutative. So how do you determine whether star is commutative? You can either use letters or numbers. So I'll start by using letters and then show you also how to use numbers. So when you're using letters, you can say for commutative, you can say for commutative, we just show them to say A star B should be equal to B star A. So we find A star B using this expression. So A star B using the expression, you take, or you can say taking the right hand side. So the right hand side is simply just this one. So we find B star A, which is just equal to, using this expression, while there's X, we put B, while there's Y, we put A. So we say B times A over 5, which can also be written as A times B over 5. So we also take the right hand side, taking the left hand side in this case, the left hand side. So the left hand side is simply just equal to A star B. So the left hand side is simply just this part, A star B. So A star B is simply just equal to, we replace A and B in this expression. While there's X, we put A. While there's B, we put B. Oh, sorry, while there's Y, we put B. So we're going to have A, B over 5. So when you compare this one here and this one here, you discover that they are the same. Hence, you can now conclude to say, since A star B is equal to B star A, then star is commutative. That is how you solve it. If you want, you can just pick any two numbers. You can just say, okay, I'll test for 2 star 3 and 3 star 2. For commutative, this should hold. Hence, you proceed by finding the left-hand side. So the left-hand side is simply just 2 star 3. So 2 star 3 is simply just equal to, while there's X, you put 2, while there's Y, you put 3. So we say 2 times 3 over 5. So 2 times 3 is simply just 6, then over 5. So the answer is 6 over 5. Let us also find the right-hand side. The right-hand side is equal to, the right-hand side will be equal to 3 star 2. So 3 star 2, which is equal to, while there is X, we put 3, while there is Y, we put 2. So we say 3 times 2 over 5. So 3 times 2 is still going to be 6 over 5. So since we have found the same answers, the first one here gave us 6 over 5. Even the second one here gives us 6 over 5. You can now conclude by saying, since the left-hand side is equal to the right-hand side, since the left-hand side is equal to the right-hand side, then star is commutative. So you can either go by the number formula or using the letters. You'll still be marked correct. Okay, same applies to associative. Associative, you also do the same. So for associative, you're also going to do the same. So I'll go on the next page for associative. So associative will also have to prove that A star B star C in brackets this side should be equal to A star B star C. We change the brackets, we shift the brackets. So on the left-hand side, for the sake of maybe space, let me just let me just take it the way it is supposed to be. So the left-hand side is equal to A star B star C in these brackets. So the left-hand side will therefore be equal to, we start with A star B, or let me not write them here. I'll be following them down here. So A star B, meaning in that expression which we had, the expression was simply just xy over 5. So while there is x, we put A, while there is y, we put B, and then over 5. Then we say this whole thing star C. So we're going to have the first, this first expression here becomes our x, the second expression becomes our y. So while there is x, we put this, while there is y, we're going to put that. So while there is x in the expression that we had, which was x star y is equal to xy over 5. So in this expression, while there is x, we put ab over 5. So we're going to put ab over 5. then we multiply everything by C, which is our y in this case. So we'll multiply everything by C, then we're dividing everything by 5 again. So some of you who wrote, there was something that you wrote, I marked you correct, not because you got the correct answer, but at least you tried. Okay, so this is, when you simplify this, you're going to have A times B times C, you're going to have A, B, C, and then divide by 5, divide by 5 there. It's not 1. You are dealing with division here. You go back to the simplest division rules. This is going to give you 25. This is just the same as 5 times 5, which is 25 down. Okay, so let us also deal with the right-hand side. So the right-hand side is going to be A star. So in brackets there, we have B star C. So meaning we start with while there's X here, we put B, while there's Y, we put C. So we're going to have B times C over 5. So this one becomes our B, this whole part becomes our B, then this one becomes our A. I'm sorry, this whole part becomes our Y, then this first part becomes our X. So while there's X there, we'll put A, while there's Y, we're going to put BC over 5. So while there's X, we'll put, where there's X there, we're going to put A, while there's Y, we'll put BC over 5. BC over 5. So this is what we're going to have. Then everything divided by this 5 there. So this will also give us A times B times C will give us A, B, C. And then divided by 5 times 5 there will simply just give us 25. So we can see that the right-hand side is equal to the left-hand side. Hence, star is associative. So before we can proceed, do we have anyone with a question? Okay, so the other question is this one here. To evaluate star 3, star 2, star 5. So the reason why I'm not erasing all these things which I'm solving, I'll send both the recorded session and the solutions. Yeah, the solved solutions. Yeah, so I'm not erasing anything. I'm going to send everything the way they are. So we move on to the second last part. This one, evaluate 3, star 2, star 5, using that same expression. So X, we know that X star Y is equal to X Y over 5. So to find 3, star 2, star 5, and then the brackets are here. Let me see where the brackets are. Okay. So we first deal with what is in the brackets there. So what is in the brackets, we have 3 and 2. So we multiply 3 times 2 over 5. Then everything we say star 5. So 3 times 2, the answer is 6 over 5. Then we say star 5. So 6 over 5 becomes our X, and then our Y becomes 5. So while there is X in this expression there, while there is X, we're going to put 6 over 5. So we're going to have 6 over 5 times 5, and then everything divided by 5. So we divide everything by 5. So when we simplify this expression, we're going to have, okay, let me write it properly so that people can see what is written there. Okay. So we said, let me also just write small things, at least things that I want everyone to see what is. Okay, so 3 times, we have star 5 here. So 3 times 2, we said this is 6 over 5. Then we have star 5. So this one becomes our x, this one becomes our y. So we say 6 over 5, that is our x. We replace it where there's x there. So we're going to have 6 over 5 times 5, then everything divided by this 5 there, which is down the numerator, the denominator. So 6 over 5 times 5, this will just give us 6, and then 6 divided by 5 will simply just give us 6 over 5 again. So the final solution is simply just 6 over 5, not what I saw most of you got, but at least some of you knew the procedure, though you got the wrong answer. Okay. So let us quickly move on to the part which no one got, at least one person tried. The question is, does it have an identity element? If yes, find the element, find the identity element, and hence find the inverse. So the question is asking us to determine whether it has an identity element, and then if it has the identity element, we have to proceed to find the inverse. So how do you find the identity element? Remember what we said. We said if you have the function, or you have the element A star, the identity element, the answer that you are supposed to get should just be A. This is also true for E star A. The answer that you're supposed to get is supposed to be is still supposed to be A. Okay, so we're going to use the first one there. You can use the second one, which I wrote this side, or you can get this one. You still get the same answer. So from this expression that we have, which is x star y is equal to xy over pi, we find A star E. So A star E is simply just, while there is x, we put A, while there is y, we put E. So we're going to have A, E, and then everything divided by 5 is equal to A. So when you cross multiply, you're going to have A, E is equal to 5A. We divide by A, we divide by A this side, divide by A this side. The answer that you're going to have is E is equal to 5. So now, since the value of E, which is the identity element, is independent of A, it means that the expression, the answer there should be yes, it has an identity element. So if you had maybe after solving, if the answer that you found was maybe A, you had maybe something like this. If the final answer, when you make E the subject of the formula, you find maybe 2 plus 3A. If it still has A, it means that it has no identity element. So the identity element should be independent of A. So if you make E the subject of the formula and then you find the answer to be maybe 3 or 32A, the answer is no, it has no identity element. Why? Because E is not independent of A. E still has A in it. So if it still has A, it means that it has no identity element. But if the identity element E is independent of A, in short, the identity element should just give you a constant. The answer, every time you're finding the identity element, it should just give you a constant. When you find anything else apart from a number or a constant, it means that it has no identity element. You don't have to proceed to find the inverse. Any function or any operation that has no identity, it means that it has no inverse as well. So now, since this one, we've discovered that E is independent of A, we've discovered that it has an identity element. Hence, let us now proceed to finding the inverse. So we find the inverse now. Let me just erase the down part. So let us find the inverse. So how do you find the inverse? We know to say anything, for example, I like using 2. When you have 2 times its inverse, the answer is always 1. This one is not the case for everything. For matrices, it's different. You get something else. So this one is therefore just called the identity element. So when you multiply an element with its inverse, the answer should always be an identity element. So what does this mean? It simply means that if we find the operation between A and its inverse, so A inverse, the answer should give us what? The identity element E. So we're going to say let the inverse of A be equal to B so that we don't get confused as we are solving. So in other words, where there is A inverse, we put B. Hence, A star B should be equal to what? E. So from this expression that we have, this one, we're going to say, we're going to find A star B. So A star B is equal to A times B over 5. I've just replaced A and B where there's X and Y. So we said A star B should give you what? E. So A star B should give us E. And the value of E in this case is simply just 5. So we equate this to 5. Hence, A times B, rather, let me just write it the way it is, AB. A times B, which is just AB, is equal to, when you cross multiply there, 5 times 5 will get 25. So we make B the subject of the formula because we said A inverse is just is just B there. So we make B the subject of the formula. So B will just be equal to 25 over A. So 25 over A is the value of B. Hence, remember we said A inverse is equal to B. Therefore, while there is B, we can replace back the inverse, which we can say, therefore, A inverse is equal to 25 over A. Therefore, the inverse of this function is 25 over A. This is the identity element. Sorry, this is how you find the inverse of the expression. This is how you find the inverse of the expression. Yeah, so you discover that when you multiply this expression, with the original function, so in this case, the value of A was X in short. I've actually even, let me not say made a mistake, but I was supposed to use X and Y. But in this case, I've used A and B. Anyway, it's fine. You can just replace back where there's X, you put A, then where there's Y, you put B. So where there's B, you put Y. Rather, where there's B, you just, B is just A inverse in short. All right, so this is the inverse function. So you can try and test it. You multiply this times that, you get the answer that is, you find the value of A star A inverse. The answer that you're going to get to simply just be 5, which is the identity element. All right, do we have any questions? Yeah, so if you want to revise through what I've taught, you can find time to go through the recorded session. I'm going to send it as soon as I finish, as soon as we end the meeting. All right, so I'm also going to send the document where I was solving these same solutions. I'm not going to erase anything. Okay, thank you very much for attending tonight's lesson. So we're going to quickly switch to ITC. Okay. I'm ending the session.